Hello friends, in this video we will discuss about one more problem which involves the use of the concept of the continuous time Fourier transform. The problem goes like this. It is given that a cascade of two LTA systems is given. The corresponding impulse responses are given to be h1 of t and h2 of t. Okay, to solve this problem, and the problem is you have to evaluate the overall impulse response of the system, and because the LTA systems are cascaded, definitely the overall impulse response would be the convolution of individual impulse responses. So you will get h of t to be equal to h1 of t convolved with h2 of t. So before we solve this problem, so we have to understand three important things. You have to understand three important results which are given below. So they are: the Fourier transform of the signal sin wt by pi t would be a rectangular signal from minus w to plus w. That is the first result. And the second result is the convolution of two rectangles of different width will result in a trapezoid. Note that the width of the first rectangle is 2t1 and the width of the second rectangle is 2t2. The resulting signal is a trapezoid from minus t1 minus t2 to plus t1 plus t2. So intermediate time limits are as given below, and the amplitude of the resultant signal would be 2a1 a2 times minimum of t1 and t2. So this is again very important result. And apart from that, we will use the third result, which is nothing but convolution in frequency domain property, which says that for two signals x1 of t with Fourier transform x1 of j omega and x2 of t with Fourier transform x2 of j omega, the product of these two signals in time domain results in convolution of the corresponding Fourier transforms. That scaling factor 1 by 2 pi will come into the picture. Okay, so with the help of these three results, let us solve the given problem. So the problem is to find the convolution h1 of t convolved with h2 of t. Okay, so we will take the help of these three results and then proceed. Okay, right. So if you look at the first signal, so we have was signal to be sin 2t by pi t. So by using the first result, the Fourier transform of that would be a rectangle from minus 2 to plus w. Why? Because so w for this signal is 2. In a similar fashion, for the second signal sin t by pi t, we again will have a Fourier transform which is a rectangle from minus 1 to plus 1. Again, why? Because w here is 1. Okay, now if you multiply these two signals, okay, so we will get sin t by pi t multiplied with sin 2t by pi t. Note that this is nothing but multiplication of the time domain signal. So clearly the third result which we have seen before says that if you multiply two signals in time domain, that corresponds to convolution in frequency domain, and hence we will get 1 by 2 pi times convolution of this signal, convolution of this signal, and convolution of this signal, and hence the final result would be convolution of two rectangles of different width. So first rectangle is of width 2 and second rectangle is of width 4. So clearly we have seen that using the second result, which states that convolution of two rectangles of different width will result in a trapezoid. Okay, so the signal trapezoid will be from minus 3 to plus 3, and the corresponding amplitude would be 2a1 a2 minimum of t1 and t2. So it is 2 times. So how did we get this 2? So this would be equal to 2 times a1 is 1, a2 is 1, and this would be equal to minimum of 1 comma 2, and clearly this simplifies to 2. And before we go to the next one, so if you multiply the time domain signal here with 2 pi, so here also in Fourier domain also you have to multiply with 2 pi, and hence these two will get cancelled, and finally 2 pi times sin t by pi t multiplied with sin 2t by pi t will have this as the Fourier transform. So clearly from minus 3 to minus 1, the equation of straight line would be 3 plus omega, and from minus 1 to plus 1 the amplitude would be 2, and from 1 to 3 equation of straight line would be 3 minus omega. So now final goal is to find h of t, which is given by h1 of t convolved with h2 of t. So h1 of t would be sine 2t by pi t, and h2 of t would be sine t by pi t multiplied with sine 2t by pi t. Okay, yes. So if you go to Fourier domain, so what happens? H of t will have h of j omega as a Fourier transform. Convolution in time domain corresponds to multiplication of the Fourier transforms. Okay, so h1 of j omega would be a rectangle from minus 2 to plus 2. Why? Because so h1 of t is sine 2t by pi t, and hence the corresponding signal will have Fourier transform to be a rectangle from minus 2 to plus 2. Okay, and h2 of j omega, we have already seen that it is a trapezoid from minus 3 to plus 3. So if you multiply these two functions, h1 of j omega and h2 of j omega, the final result would be from minus 2 to plus 2 with this shape. So clearly the equation of this line, because it is just multiplication, the equation of straight lines are not going to change, and hence the equation of these two straight lines would be 3 plus j omega and 3 minus j omega respectively. So the product of these two signals, which is nothing but our h of j omega, will look like this. But the question is to find h of t, and hence to solve that, so let us rewrite h of j omega here. Okay, so this is our h of j omega. So with little bit thought, we can see that this h of j omega can be written as summation of this function, which is a trapezoid, and summation of this function, which is a rectangular function. Okay, and but the corresponding equations would be, so equation of this line would be 2 plus omega, and the equation of this line would be 2 minus omega. So this is just h of j omega, and hence the equation of this line is 3 minus omega. Equation of this line would be 3 plus omega. So clearly, if you see from minus 2 to minus 1, equation of this line is 2 plus omega, and from minus 2 to minus 1, this line is 1, so finally you will get 3 plus omega. Similarly, from 1 to 2, this is 2 minus omega, so from 1 to 2, this is 1, so 1 plus 3 minus omega would be 3 minus omega, and hence we can write our h of j omega to be summation of this signal and this function. Okay, summation of this function and this function. But just now we have seen that once you have a trapezoid, we can see it as convolution of two rectangles of different width, and hence this trapezoid can be written as convolution of two rectangles, first rectangle of width plus 1 and second rectangle of width plus 3. So if you convolve these two signals, you will get this trapezoidal signal. So now if you go to time domain, so what will happen? So because there is no 2 pi term, so 2 pi scaling factor will come into the picture, and because it is convolution in frequency domain, in time domain, it will be just multiplication of the corresponding inverse Fourier transforms, and hence for first one, inverse Fourier transform would be sine t by 2 by pi t multiplied with sine, this fellow will have sine 3t by 2 by pi t as the Fourier, inverse Fourier transform. Okay, so similarly this fellow will have h of t as the inverse Fourier transform, and similarly this fellow will have sine 2t by pi t as the inverse Fourier transform. So clearly we can summarize that our overall impulse response h of t would be 2 pi times sine t by 2 by pi t multiplied with sine 3t by 2 by pi t whole signal added with sine 2t by t. Okay, hope this problem helps you in understanding the concepts of Fourier transform and convolution operation. Thank you.